We're going to look now at Venn diagrams and two-way tables on page 810. That was a lie. On page 495, 8.10. We're going to use Venn diagrams and two-way tables when two independent events are being considered. Now, what's the difference between the two? A two-way table lists the number of outcomes in different categories, with the final row and column being the total of the entries in that row and column. So in this case, we were looking at people like maths, who do not like maths, people who like English and do not like English. Now, like maths, there's a total of 33 people. People who like maths, 67. So total students, number of students are 100. Out of this, we can also see people like English. 28 of those who like English like maths, and 33 of those who like English also do not like maths. So in total, there's 61 who likes English, and there's 39 who do not like English. All the columns and totals needs to add up to 100 at the end. The Venn diagram is just a pictorial representation of this. So you need to be able to go from this to this, or from this to this. It's the same information. What do we see here? We say 34 people like neither maths nor English. Do not like English, do not like maths, 34. People who like maths and English, 28. People who like maths and who like English is 28. So this is just a picture of what's actually happening here. Let's look at example 14, constructing Venn diagrams and two-way tables. A survey is conducted of 50 people asking who likes coffee and who likes tea. It has found that 20 people like both. 15 people like coffee but not tea, and 10 people like tea but not coffee. How many people like neither tea nor coffee? So 10 people, 50 people altogether, asking who likes. It's found that 20 people like both, 15 people like coffee but not tea, and 10 people like tea but not coffee. So you can see it's pretty hard to see how many there are. I'm going to start straight away and write this into my Venn diagram. I'm going to name this Venn diagram. I'm going to say this is coffee, and this is tea. I'm going to go and look at what they say. A survey is conducted 50 people altogether. 20 people like both. So that's pretty easy. 20 people like both of them. 15 people like coffee, so they like coffee but not tea. So they like coffee but not tea, which means that this must be 15. And 10 people they like tea but not coffee, so they need to be in tea but not coffee, and that needs to be 10. Altogether, this must add up to 100. So the number of people who don't like coffee and don't like tea either, so for A, I can say that I know that altogether there's 50. Of that 50, 20 like both, 15 like only coffee, and 10 only like tea, which means the number of people who don't like anything equals 5, and I can write the 5 on the outside. Now, I've done A, I've done B. How many people surveyed liked tea? So to do that, I'm going to look at this. How many people like tea, which means that is the number of people who like tea. So that total number of people liking tea, so that's C. How many people like tea? The number who like tea equals 20 plus 10, and that equals 30 people. How many people like both coffee and tea? So people liking coffee and tea will be, they like coffee and tea, but they also like coffee and tea. Like both coffee and tea. That will be only the 20 up here. So that will be only the 20 that like both coffee and tea. So I'll say the number that like coffee and tea equals 20. In E, I want to know how many people like coffee or tea or both. And this is when we're going to say, well, that is everything that's on the inside. So this is all of this who likes coffee and tea. So the number that like coffee and or tea will equal 15 plus 20 plus 10, that equals 45. The last one is F. Representative survey finding in a two-way table. So I quickly drew the table, and what I'm going to have is going to have coffee on the one and tea on the other. So let's start off in saying this is I like coffee and I do not or dislike coffee. Dislike coffee. This will be a total column. This is like tea and I dislike tea. I really do dislike tea, and this will be a total. So how do I draw the one from the other? The easiest one is to start the one that is coffee, like coffee and tea. So I like coffee and like tea, that will be 20. Liking coffee and liking tea. The total, I know, the total down here should be 50 because there were 50 people. Okay, so how many people like tea? If I close this bit like that, so how many people liked tea? 20 plus people, 10 people, total is 30, so 30 people like tea, which means 10 people like tea, but they don't like coffee, so that needs to be a 10. Okay, like coffee, but dislike tea. So like coffee, but dislike tea. Like coffee, so they like coffee, but they dislike tea. That will be 15. The total will give us 35. And let's just check there if there's how many people like coffee altogether. If I do this, people liking coffee, 15 and 20 is 35. I can now finish the table because 35 plus 15 will give us 50. Let's see how many people dislike coffee. People who don't like coffee at all. These people don't like coffee, so it's 10 and 5, which gives us 15. Okay, which means 10 and 5 will give us 15. Is that true? People who don't dislike coffee and they dislike tea, so they don't like coffee or tea, so that is the 5. That's where that 5 comes from. 15 and 5 will give us 20, and my final check, 30 and 20 equals 50. Where does this 20 come from? This 20 is people who dislike tea, so people who don't like tea. People who don't like tea, those are the people who don't like tea. 15, and that 5 that's hiding there, that is the 20 that we have over there. Good. I would like you to go now to your timeline and go do some of these questions.